Selvam, and my metric number is 8P180191. Okay, I will explain about the bridge and the building that I built using the Revit software. First of all, let me see the building. Actually, this is a suspension bridge that the idea the idea to build the bridge I took from the Cittadella bridge from Italy. So as we can see here, I am designed a three column for this bridge to support the deck of the bridge, and we have a two building is connected in the middle of the bridge. That's all for me. Thank you.
So as for supporting beam, so here is the specification on above, and below is the materials and size. I choose P times H 200 times 550, durability and loading analysis. This is how beam safe weight. And for the shear strength, we got 27.9 kNm and bending moment 41.85. And as for main reinforcement effective depth, okay, we got D498, D prime 5052, and val 207.08, and K val 0167, and K is 0.185, and then Z, so area of steel, area of tension. And as for the shear reinforcement, the VED 27.9, and shear length 0.575, spacing S, and so we use hash 6, which is equal to 200, and X SS for deflection. So PO equal to 0.012, and when we calculate everything, then actually LD actual is smaller than LD allowable. So as for cracking, max allowable bar spacing 200, then S equal to 2 to 3 mm, which is larger than 200, so then okay lah. As for shearing, 0.575, and then spacing S. So here is the detail, how it looks like. Yeah, the detail. Alright, that's all.
My name is Lee Siwon, and now I'm going to present the calculation for the slab, and this is the specifications for the slab. First, we get the value of hash is 133.33, and last we try to use hash is equal to 150, while for the nominal cover, we get the value of 35 mm. And design actions, after using the formula, we get the value of 15.38 kN per m squared. And the moment for the short span is 25.59 kN per m, and the long span is 11.32 kN per m. And last, we get the area for the short span is 469 mm square, and the long span is 236 mm square. And the shows we get a conclusion, which is VRDC, which is 45.9 kN, is greater than VED, which is 13.76 kN. And the actual span effective depth is 36.36, which is smaller than the allowance, which is 45.82. And for the cracking part, we know that hash is equal to 150 mm, which is smaller than 200 millimeters. And for the main bar spacing is 350, which is smaller than the maximum slab. And the secondary bar is also smaller than the maximum slab, and the value is 300. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fazul Rafiq Benjalani, number metric AP180337. So, I would like to explain about the column in my project. For the dimension and size for column is 3 to 5 times 400 mm. So, for the LZ is 7,400 and LY is 7,500. And for the result that I get in my project, for slenderness ratio is for Z is 36.5, and then for Y is 41.50. My column is non-slender column. Next, we go to the design of moment. So for the calculation, I get the answer is 47.6 kilonewton meter, and the reinforcement is, for the minimum is 172.4 millimeter square, and AS maximum is 5,200 millimeter square. That's all. Thank you.
Okay, for the conclusion, some theoretical background to understand the dynamic behavior of pedestrian bridge were discussed. Comparison of proposed design codes methods were also presented due to the average frequency range for walking and running. Critical acceleration computation should be computed when the natural frequency is lower than 5 Hz. This could lead to the change of the design or addition of tuned mass damper to control the vibration. The method proposed are recommended since they are simple and reflect the current state of knowledge. More research is needed, in particular for crowd loading, which is not properly accounted for many design codes. Full-scale dynamic tests carried out on a several pedestrian bridge could lead to a well-documented database that is required to understand the dynamic behavior. Thank you.